Okay, welcome to Unit 4, Lesson 3, which is on graphing polynomials. So in the first two lessons, we kind of looked at how to analyze a graph, how to look at it and tell different features of it. In the second lesson, we looked more at the equations and how to analyze that, and a little bit with the graphs, with multiplicities and things such as that. Today, we're going to kind of put it all together and kind of work our way backwards, where we're going to be given certain characteristics and certain equations, and we're going to use that to create the graph. Okay, so the first thing we're going to talk about here is the cubic function. And so the first couple here are in transformational form. This may look very familiar to you. It's the vertex form of the quadratic, except that our exponent here is a 3 instead of a 2, which makes it cubic. But with the same kind of basic ideas, that we're going to have a key point, and that would be 1 comma negative 2. But it's not a vertex per se, because in cubics it's an inflection point. You don't need to know that name, but you should know that this is a key point for the graph. Now, many of you may be familiar with, we talked about the delta x and delta y, or the quadratic motion. So we're going to look at the same thing, except we'll look at what's called cubic motion. And we'll look at negative 2, negative 1, 0, 1, and 2. So negative 2 to the third power would be negative 8. Negative 1 to the third power would be negative 1. 0 to the third, 1 to the third, and 2 to the third. So that gives us kind of what's happening from our key point. If I move backwards 2, I should go down 8. Backwards 1, down 1. That's our key point. Over 1, up 1. Over 2, up 8. So that's the delta movement. Now, again, our key point is going to be 1, negative 2. And here we see that it's been reflected, which changes our y values. So we'll just change the sign of all of those y values. And then we'll go back here, move back 1, up 1, back 2, up 8. And then over 1, down 1, and over 2, down 8. It kind of goes off the graph there a little bit. And then kind of draw this kind of motion. We see our inflection point, which we've talked about a little bit, where it kind of seems to curve off and then curve back down. So that's the graph in vertex or transformational form. So I would like for you to kind of try this over here. Make your little chart. It's going to be the same as the other one, but I would like for you to try to graph this on your own. So pause the video and then try to create the graph here. Alright, go ahead and pause the video. Okay, and here's the answer you should have. Again, when it's inside the parentheses, when you bring it out, it's always the opposite sign. So x plus 2 becomes negative 2, negative 1. Again, your quadratic motion should be the same. It's not been reflected, so that's not going to cause any kind of changes in the values. So that's our cubic in transformational form. Alright, so just be able to do that. And now we'll look at a little more complicated different drawings here. Now the first thing I want to do here is to kind of make this readable, is we're going to change that 4 into a 1. Alright, that way we can actually kind of graph it onto the graph that I have here. And you'll see why a little bit later on. So let's make that a 1 again. So we talk about our zeros with our multiplicities. So my first factor is x plus 1. So that would give me a 0 of negative 1. The exponent's a 1. So I'm just going to throw my multiplicity up here to kind of save space. X plus 2 gives me a multiplicity of negative 2. I'm sorry, a 0 of negative 2. Multiplicity of 1. We have a x minus 1, which gives me a 0 of 1 with a multiplicity of 1. And x minus 3 gives me a 0 of 3 with a multiplicity of 1. Okay, now I can turn all of these zeros into x-intercepts by just writing it like a point. -1, 0. -2, 0. 1, 0. And 3, 0. So now to figure out my y-intercept, well, x-intercepts have y values of 0. Y-intercepts have x values of 0. So if x is 0, what would I get here? Would that be 1 times 2 times -1, which is -2, times -3, which would be +6. But then it's been reflected, so that +6 becomes -6. And that's my y-intercept. My degree would be a matter of counting up. What do I have here? I have first degree, 1, 2, 3, 4. So this is a fourth degree. And it is negative, so I can think about my end behavior. Negative functions go down on the right. Even functions do the same thing, so that would make this also negative infinity. And that's going to be important for when I graph. So kind of working with our multiplicities, working with our x-intercepts, let's put these 5 points on the graph. -1, 0, -2, 0, 1, 0, and 3, 0. And then we put our y-intercept of 0, -6. And of course, we know that all the multiplicities are 1, so they're just going to kind of be moving through. So the next thing I'm going to look at here is my end behavior. So I know that it starts below and goes through here. Now, I'm not too concerned about where my turning point is for this graph. I'm just kind of sketching a rough idea. I know it hits that, and then it's going to come back up. It has to go through again. And then I know that it's going to come back down, and that's really what I know is happening here, right? I get the correct end behavior with the correct multiplicities. If I was to mess up any of these multiplicities, it either wouldn't go through my y-intercept, or I wouldn't have the correct end behavior. So those are key indicators to let you know whether or not you've done it correctly. All right? So why don't you go ahead and pause the video, try number 2, see if you can complete the questions and get a rough sketch of the graph. All right, go ahead and pause the video. Okay, so here you should see the answer to number 2. We're here with a -1, and again, all these multiplicities are 1. So -1, 2, and 3, your x-intercepts. Y-intercept, let me just kind of fix that parenthesis. Don't know why I did that. Alright, so 0, 6, third degree, -infinity, infinity. Again, when I put my x-intercepts on the graph and my y-intercept, my end behavior, it starts low, comes through my y-intercept. At some point it needs to turn around, come back through, turn around at some point, come back through. As long as it's going through my x-intercept correctly, I'm hitting my y-intercept, and I'm getting the correct end behavior, then you're going to have a graph, a sketch of a graph that we care about. All right? And you're going to demonstrate that you understand all these different parts. So now we're going to kind of step it up a little bit. We're going to have some equations with higher multiplicities than 1. Other than that, this is going to be pretty much the same thing. So I have a 0 of 0. That multiplicity is 1. I have a -2 that has a multiplicity of 2. And I have a +1 with a multiplicity of 3. That gives me x-intercepts of 0, 0, -2, 0, and 1, 0. A y-intercept, so if I plug a 0 in, that's going to be 0 times whatever, it doesn't matter, it's going to be 0, 0, which makes sense because that's the x-intercept as well. So the degree here, I'm counting up, this is 1, 2, 3, 4, 5, 6. So this is a 6th degree function. My end behavior, right, it's a positive function, so I know that this is infinity. It's even, so I know they'll be doing the same thing. Okay, so now let's kind of do the same thing we did before. We'll sketch these zeros. Now, again, this is going to start high. So this 0 of -2 has a multiplicity of 2, which means it's going to be bouncing. So it's going to be coming down, it's going to bounce. Now at some point it's going to have to turn around because it goes through here, and then it's going to come back up, kind of level off, and then come back up. So this is what's kind of tricky because it's so close, but as long as we see that little kind of flattening out on the x-axis and then a shooting up, then we'll know that you kind of get a multiplicity of 3 there. As long as it doesn't go straight through, such as this one. You should be able to see the difference between these two. This is a multiplicity of 1, this is a multiplicity of 3. So again, anything kind of resembling this with the correct end behavior, the correct points, and the correct multiplicities would get full credit. Okay, so before you begin this one, again I want to make a slight alteration. We're going to change this 4 into a 1. Again, it's going to help make the graph graphable. So let's go ahead and give this a shot. Pause the video, see what you can do. Again, be careful, this was reflected, and this is now a 1. Alright, so try to graph this, and then when you're done, come back and you'll see the answer. Alright, pause the video. Okay, so this should be your graph. It should look pretty similar to this with your zeros, your x-intercepts, your y-intercept, your 4th degree, your end behavior. Again, because it's negative, this is negative. It's even, so it's doing the same thing. And then you should be able to have this graph, right? It starts below, comes up, bounces with a 2 multiplicity, hits the y-intercept, comes back down with a linear multiplicity of the last one. Alright, so that should be what you have. And now we'll step it up a little bit more, where we're just given information, right? So trying to figure out what to start with here, I would say start with your zeros, right? So I have a 0 at 3, and I have a 0 at -2. Now note that's a multiplicity of 2, so that's going to bounce. It's either going to be above and bounce or down below and bounce. So let's see, relative max at 1, 2. Alright, that's a maximum. And I have a minimum here at 0, -2. So that's a minimum. So it's negative, 5th degree, which means it'll be odd. So it's going down at the end and up in the beginning, which makes sense because it's going to bounce there. At some point, it's going to come back down from that point, and it's going to go through that other x-intercept, right? Because it's negative, it goes down on the right. It's odd, so it goes up in the beginning. I have a 0 of 3, a 0 of -2. So that accounts for 3 of my solutions from the 5th degree, which means at some point there are 2 imaginary, but with the graph I have no way of telling where those imaginary solutions are, so don't even worry about that on your graph. Relative max of 1, 2, relative min of 0, -2. So there's your graph. Alright, so try to use that same kind of technique and try to graph number 4 here. Pause the video, give it a shot, and when you're done, come back and check your answer. Alright, pause the video. Okay, so this should be what you have, right? If you look at your zeros of -4 and 0, turning point at -2, -3. So I got all my points on the graph. Thinking about my end behavior, I'm going to start high. And I'm going to come down. My first, this is a multiplicity of 3, so hopefully you see that that's kind of leveling out. And it is coming in and then shooting back down. So hopefully you see that there, right? And that probably made it a little bit hard to see. And then hit the turning point, and then a single linear multiplicity there. So hopefully your graph looks very similar to this. At least you should have the 3 points and should be going up in both directions. Alright, that's it for the video. We'll come into class and we'll practice all of this, and we'll go back and practice some of the first couple days lessons as well in the classwork. So if you have any questions, let us know. Otherwise, we'll see you in class.